Computational problem solving, algorithms, abstraction, and digital logic. This is Maya and her robot friend Momo. Every app, game, or website they use works because computers follow a clear set of instructions. These instructions tell the computer what to do, step by step. This process is called computational problem solving. It helps break problems into smaller steps, find patterns, simplify complexity, and solve tasks correctly. Algorithms are step-by-step instructions. Abstraction is simplifying complex problems. Digital logic is about how computers make decisions. An algorithm is a set of clear instructions to solve a problem. It has a start, steps, and an end. For example, an algorithm for logging into an online exam checks the username, verifies the password, and grants access if everything is correct. Another example, finding the highest marks in a class. The algorithm compares each mark and keeps track of the highest one until the top scorer is found. Algorithms are logical solutions, but when we write them in a programming language like Python, Java, or Scratch, they become a program, the practical implementation of the algorithm. Search algorithms help find information fast. Linear search checks one item at a time. Binary search divides sorted data to find items faster. Sorting algorithms arrange data in order. Bubble sort swaps numbers until sorted. Selection sort repeatedly finds the smallest number. Storage algorithms help store and retrieve data efficiently, like saving files, database records, or memory management. Abstraction means hiding unnecessary details and focusing on what matters. It reduces complexity and makes systems easier to use. When driving, you only see the wheel and pedals, not the engine. In apps, users see buttons and screens, not the internal logic. For example, in an online shopping app, user level, browse products, add to cart, place order. Logical level, calculate totals, apply discounts, check stock. System level, database queries, payment gateway, server code. Computers make decisions using digital logic. Computers make decisions using digital logic. Values are 1, true, or 0, false. Logic gates use these values to decide outputs. Logic gates control how computers make decisions. And needs both true or needs 1, not flips values. NAND is the opposite of and XOR is true when inputs differ. Logic gates power traffic lights, security alarms, automatic doors, and processors. They let computers make decisions automatically. With these skills, Maya now understands how apps and systems follow clear instructions, simplify complexity, and make intelligent decisions.